CCNA, Cisco Certified Network Associate. Course title, CCNA, Cisco Certified Network Associate. Course description. This course is designed to provide students with an in-depth understanding of Cisco networking technologies and prepare them for the Cisco Certified Network Associate, CCNA, certification exam. The course covers topics including network fundamentals, LAN switching technologies, routing technologies, WAN technologies, infrastructure services, and security. Module 1, Introduction to Networks. Networking models and protocols. Networking models and protocols are essential concepts in computer networking. They provide a framework for understanding how data is transmitted between devices and across networks. There are several networking models and protocols that are commonly used in the industry. Here are some of the most important ones. 1. OSI model. The Open Systems Interconnection (OSI) model is a theoretical model that defines the different layers involved in the transmission of data over a network. It consists of 7 layers, each with its own set of protocols and functions. 2. TCP/IP model. The Transmission Control Protocol/Internet Protocol (TCP/IP) model is a practical implementation of the OSI model. It is the protocol suite used on the Internet and many other networks. It consists of 4 layers: the application layer, transport layer, Internet layer, and network access layer. 3. Ethernet. Ethernet is a family of networking technologies that is commonly used for local area networks, LANs. It is the most widely used LAN technology and is based on the IEEE 802.3 standard. 4. Wi-Fi. Wi-Fi is a wireless networking technology that uses radio waves to provide high-speed internet and network connections. It is based on the IEEE 802.11 standard and is commonly used in homes, offices, and public spaces. 5. DNS. The Domain Name System (DNS) is a protocol that is used to translate human-readable domain names, such as Google.com, into IP addresses that can be used by computers to connect to the Internet. 6. HTTP. The Hypertext Transfer Protocol (HTTP) is a protocol used to transfer data over the web. It is the foundation of the World Wide Web and is used to retrieve web pages and other resources from servers. 7. FTP. The File Transfer Protocol (FTP) is a protocol used to transfer files between computers over a network. It is commonly used for transferring files between a client and a server. 8. SMTP. The Simple Mail Transfer Protocol (SMTP) is a protocol used for sending email messages over the Internet. 9. SNMP. The Simple Network Management Protocol (SNMP) is a protocol used for managing and monitoring network devices such as routers, switches, and servers. 10. IPsec. The Internet Protocol Security (IPsec) protocol is a suite of protocols used to provide secure communication over IP networks. It is commonly used for virtual private network (VPN) connections and to secure Internet traffic. These are just a few examples of the many networking models and protocols that are used in computer networking. Each plays a critical role in enabling devices to communicate and share information over networks. OSI and TCP/IP models. The OSI, Open Systems Interconnection, model and the TCP/IP, Transmission Control Protocol/Internet Protocol, model are both networking models used to describe how data is transmitted between network devices. The OSI model has 7 layers. 1. Physical layer. This layer deals with the physical transmission of data over the network, including the physical medium used, the connectors, and the electrical or optical signals used to transmit data. 2. Data link layer. This layer is responsible for establishing and maintaining a link between 2 devices, including error detection and correction, flow control, and addressing. 3. Network layer. This layer is responsible for the routing of data between devices on different networks. It includes addressing, routing, and congestion control. 4. Transport layer. This layer provides reliable end-to-end communication between devices, including flow control, error detection and correction, and congestion control. 5. Session layer. This layer establishes, maintains, and terminates communication sessions between devices. 6. Presentation layer. This layer is responsible for data formatting, including encryption, compression, and data conversion. 7. Application layer. This layer provides services to applications, including file transfer, email, and web browsing. The TCP/IP model has 4 layers. 1. Network interface layer. This layer is responsible for the physical transmission of data over the network, including the physical medium used, the connectors, and the electrical or optical signals used to transmit data. 2. Internet layer. This layer is responsible for the routing of data between devices on different networks. It includes addressing, routing, and congestion control. 3. Transport layer. This layer provides reliable end-to-end communication between devices, including flow control, error detection and correction, and congestion control. 4. Application layer. This layer provides services to applications, including file transfer, email, and web browsing. The TCP/IP model is often used in practice because it is simpler than the OSI model and more closely reflects the structure of the Internet. Network cabling and connectors. Network cabling and connectors are critical components of a computer network that facilitate the transmission of data between devices. They provide the physical infrastructure for network communication and play a crucial role in ensuring reliable and efficient data transfer. Here are some common types of network cabling and connectors. 1. Ethernet cabling. Ethernet cabling is the most widely used type of cabling for wired networks. It is used to connect devices such as computers, switches, and routers in local area networks, LANs, and wide area networks, WANs. The most common types of Ethernet cabling are Cat5e, Cat6, and Cat6a, which are twisted paired cables that use RJ45 connectors. 2. Fiber optic cabling. Fiber optic cabling is used for high-speed and long-distance network connections. It uses glass or plastic fibers to transmit data as light signals, allowing for faster data transfer and longer distances compared to Ethernet cabling. Fiber optic cabling is commonly used in backbone networks, data centers, and for connecting geographically dispersed locations. 3. Coaxial cabling. Coaxial cabling is a type of cabling that consists of a central conductor, an insulating layer, a metallic shield, and an outer insulating layer. Coaxial cables are commonly used for television and broadband internet connections, but they can also be used for networking in certain applications. These are some of the common types of network cabling and connectors used in modern computer networks. It's important to choose the appropriate type of cabling and connectors based on the specific requirements of your network, such as network speed, distance, and environment, to ensure reliable and efficient data transmission. Proper installation and maintenance of network cabling and connectors are also crucial for network performance and reliability. Module 2. LAN switching technologies. Ethernet fundamentals. Ethernet is a widely used standard for wired local area networks, LANs, that allows devices to communicate with each other over a shared or dedicated physical medium, such as copper or fiber optic cabling. Ethernet provides a set of rules for how data is transmitted and received on a network, known as the Ethernet protocol. Here are some key fundamentals of Ethernet. 1. Ethernet standards. Ethernet has evolved over the years, and there are several Ethernet standards or variants that define the physical and data link layers of the Ethernet protocol. Some common Ethernet standards include 10 base T, 100 base TX, 1000 base T, 10 base T, and 40 base T, which define different data transfer rates and cable types for Ethernet networks. 2. Ethernet frames. Ethernet data is encapsulated into frames, which are packets of data that are transmitted over the Ethernet network. An Ethernet frame typically consists of a preamble, start frame delimiter, SFD, destination MAC address, source MAC address, ether type or length field, data payload, and CRC, cyclic redundancy check, for error detection. 3. MAC addresses. Ethernet uses MAC, Immediate access control addresses to uniquely identify network devices, such as network interface cards, NICs, and switches, on a network. MAC addresses are 48-bit, 6 bytes, hexadecimal values that are assigned by the manufacturer and embedded in the network interface of a device. MAC addresses are used in Ethernet frames to specify the source and destination devices for data communication. 4. Ethernet switching. Ethernet switches are used in Ethernet networks to connect multiple devices together and forward Ethernet frames between them. Ethernet switches operate at the data link layer, Layer 2, of the OSI, Open Systems Interconnection, model and use MAC addresses to determine the destination devices for frame forwarding. Ethernet switching allows for efficient and secure communication between devices in a LAN, as it reduces unnecessary broadcast traffic and improves network performance. 5. Ethernet media. Ethernet can be transmitted over various types of physical media, including copper cabling, such as Cat5e, Cat6, or Cat6a, and fiber optic cabling. Different Ethernet standards may require different types of media for optimal performance, and the choice of media depends on factors such as distance, data transfer rate, and environmental conditions. These are some of the fundamental concepts of Ethernet, which is widely used for networking in various applications ranging from small office/home office, SOHO, environments to large enterprise networks. Understanding Ethernet fundamentals is essential for designing, configuring, and troubleshooting Ethernet networks to ensure efficient and reliable data communication. Switching concepts and protocols. Switching is a fundamental networking concept that involves the forwarding of data packets between devices connected to a local area network, LAN, or a wide area network, WAN. Switches are devices that operate at the data link layer, Layer 2, of the OSI, Open Systems Interconnection, model and use MAC, Immediate Access Control, addresses to forward data packets to their intended destinations. Here are some key concepts and protocols related to switching. 1. MAC address learning. Switches learn MAC addresses by examining the source MAC addresses of incoming frames and associating them with the incoming switch port. This process is called MAC address learning. The switch builds a MAC address table, also known as a MAC address forwarding table or CAM, content addressable memory, table, which maps MAC addresses to their corresponding switch ports. This MAC address table is then used to make forwarding decisions when data frames need to be transmitted to their destination devices. 2. Forwarding and filtering. Once the MAC address table is populated, the switch uses it to forward incoming frames to the appropriate switch port where the destination device is located. If the destination MAC address is not found in the MAC address table, the switch floods the frame to all other switch ports, except for the incoming port, in order to reach the unknown destination device. This is known as broadcast and multicast flooding. However, switches also implement filtering mechanisms to prevent unnecessary flooding and improve network efficiency. 3. VLANs. Virtual LANs. VLANs are used to logically segment a LAN into multiple virtual networks, allowing devices in different VLANs to communicate with each other based on their VLAN membership. VLANs are configured on switches and are used to segregate network traffic, improve network security, and optimize network performance. VLANs are typically implemented using IEEE 802.1q standard, which adds a VLAN tag to Ethernet frames to identify the VLAN membership of the frames. 4. Spanning Tree Protocol, STP. STP is a protocol used to prevent loops in Ethernet networks, which can cause broadcast storms and network outages. STP is based on the IEEE 802.1d standard and uses a tree-like topology with a root bridge and designated ports to create a loop-free logical path for forwarding frames. STP dynamically selects the best path and disables redundant links to avoid loops, ensuring reliable and stable network operation. Thanks for watching. For more information, like, comment, and subscribe our channel.